Welcome to the video. This video is a part of History of Science course of Chulalongkorn University International School of Engineering History of Science course. In this presentation, we'll be covering the topic of pneumatics.
Let's start with what is pneumatic. Pneumatic has a long history playing an important role in the development of mechanical technology and various automation solutions. When mentioning pneumatic system, the hydraulic system may come into our minds. However, instead of hydraulic fluids, pneumatic system utilize compressed air to provide functionality to its mechanism instead. Basically, the pneumatic system uses compressed air to manipulate and transmit energy through different parts of mechanism. Extensively utilized in various industries, such systems depend on air compressor to allow the compressed air functionality to work. With network of pipe and valve, the compressed air can be supplied through the device systems.
Next, the advantage of the pneumatic system is pneumatic systems are fast to operate, so in each cycle it takes short time to proceed. Also, the compressed air in the system is clean, reducing contamination in the production process. Therefore, pneumatics are utilized in key manufacturing room. Moreover, the air can be recirculated into the environment without causing a pollution problem. Moreover, pneumatic systems are reliable since compressed air is not affected by the change in temperature. Lastly, individual parts of the mechanism are generally inefficient, like pressure seal, which are mostly problem-free, and in each part of the system it overgo a force within the withstandable threshold, so each part will not break easily.
As for the disadvantages, despite the ease of use for pneumatic systems, they tend to be difficult to control the speed at which system operates, since it relies on the compression of air. And if water happens to intrude the system through a leak or a damaged enclosure, the entire system can freeze up. Additionally, the damaged system of air hoses or loose nozzle can cause a potential safety hazard. Most importantly, the pneumatic system is loud during its operation. But all things considered, pneumatics has a significant applications that played major roles in the history of various industries.
Let's come to the application of a pneumatic system. There's three applications. The first one is bicycle pump. It is a type of an air pump that have a purpose of inflating bicycle tires, footballs, basketball, and others. Even though bicycle pumps seem very simple tools that people use a lot in our daily life, they also relate to the important principle of pneumatic. There are two principles that involve with bicycle pumps. The first one is airflow from the high to low pressure. A very good example is to think that to imagine that a molecule like a bunch of billiard balls. When billiard balls hit each other, it will bounce and spread out. Air molecules also collide with each other and spread out, flowing from the high to the low pressure. And the second principle is when decreasing the volume of the chamber full of air, the pressure will increase. Let's come to how a bicycle pump works. Bicycle pump has a container full of air inside them, and then when pressing down the handle of the pump, the volume of the container will decrease, and it will increase the pressure inside it. And because air moves from the high to low, so the air will flow from the container into the tank. On the other hand, when we raising the handle up, the pressure in the container will decrease, resulting in a rush of air inward from the outside of the mechanism. In a regular use case, air will travel in reverse into the gas chamber from the tank. In the process, the pressure within the container will be reduced, in contrast to bicycle pumps, with pumps that only allow for a unidirectional flow of air.
The second application of the pneumatic system is an airbag. Law in toward compressed airbag system. In short, brakes are the part in vehicle that assist in increasing the speed of a vehicle, not stop its movement. There are many systems of brake like mechanical brake, hydraulic brake, and pneumatic brake. In detail, George Westinghouse, who invented the first airbag that transformed the railroad accident by making a safer attempt, so allowing train to move its faster pace. So because the brake itself is safer, so it is more safe to use a brake, and with that the train can go faster without concerning about to go off the rail or crash. Pneumatic brake system work by keeping a high pressure air inside brake. When the driver press the pedal, pressure in the line begin descending. As a result, the brake is applied. This kind of brake is adopted by heavy vehicles such as truck, bus, and train. However, air braking system require vast space to deploy, and another problem of it is the cost of the system that will increase the total manufacturing cost. So it is not worth it to put it in the light vehicle like a car, although the pneumatic braking system is superior to that of a hydraulic in terms of safety and performance.
Next is the steam engine. The steam engine brought about the first industrial revolution. Going back to 1664, British engineer Thomas Newcomen invented the first practical steam engine. Newcomen's steam engine utilizes the condensation of steam that is pumped into the cylinder. This process creates a partial vacuum space that enables the weight of the atmospheric pressure to push down into the piston of the cylinder. This device is the first recorded practical use of harnessing steam to generate mechanical work. Newcomen's engine was used to pump water out of mines at the time. However, his engines are inefficient due to the tremendous amount of energy needed for operation. The steam engine needed to heat and cool the cylinder repeatedly, which wasted the energy that is used to reheat the steel. Despite its thermal inefficiency, Newcomen's machines served as the precursor to James Watt's steam engine that initiated the first ever industrial revolution. In 1765, Watt conceptualized the idea of a separate condenser, which is a device that cuts down the amount of heat waste produced by Newcomen's steam engine. Watt's steam engine, much like Newcomen's engine, operate based on the concept of pressure difference. However, Watt's implementation can remain hot at all times by allowing the steam produced to flow into a separate condenser device. The condenser is then pumped alongside other gases using the air pump. This process thereby improves the efficiency of the steam engine significantly. That is the end of the presentation. Thank you very much for your time. Have a nice day.